In this video, we're going to explore area of similar figures, and in particular, the relationship between the ratio of, say, two corresponding sides with the ratio of their areas. So let's have a look at the first point. If the ratio of corresponding sides of two similar shapes is, say, m to n, then the ratio of their areas is m squared to n squared. So a good way to understand this is if you, say, took a shape and you doubled the dimensions of that shape, what's happened to the area? The area is increased by a factor of 4. So if you took a rectangle, let's say dimensions x times y, you double the x dimension, so double x is 2x, and you double the y dimension, the vertical dimension, so double y is 2y. The area of the small rectangle is xy, but the area of the new rectangle or the new area is 4xy. So it's 4 times as big. And you could demonstrate this with, say, an A4 sheet of paper, and then take add another A4 sheet of paper to the side, and then 2 A4 sheets down, and you can see very easily that you increase the area by a factor of 4. What about tripling the dimension? So instead of x times y, we triple the dimension. So you have 3x times 3y. What happens? We end up with a new area of 9xy. So we end up increasing the area by a factor of 9. So this is where this ratio comes about, or at least one way to look at it. Let's have a look at some examples. And there's just a couple here, just some simple examples, but hopefully it demonstrates the principle. So part A, what is the ratio of the areas of the similar triangle shown? So we have the small triangle side length 2, one of the sides, and the larger triangle, its side length is 3 units. So if the ratio of their lengths is 2 to 3, the ratio of their areas would be 2 squared 2, 3 squared, which is 4 to 9. Now, just one thing I'd like to add to this. If we look at it from the point of view of ratios, this means that for every 4 units of area in the small triangle corresponds to 9 units of area in the larger triangle. If I divide both of these terms of the ratio by 4, let's say, okay, what does this mean? So 4 divided by 4 is 1, 9 divided by 4, okay, 2.25, which is 2 1/4. So this means that for every unit of area in the small triangle, the larger triangle is 2 1/4 times as big. So if this was 1 square centimeter, this would be 2 1/4 square centimeters, for example. Let's have a look at part B. Two similar shapes have their areas in the ratio 49 to 81. Find the ratio of the lengths of their corresponding sides. So this is really the converse of part A. So 49 to 81. Okay, so this is looking at their areas. Okay, 49 to 81. Taking the square root of both terms of the ratio, okay, gives us 7 to 9. So the ratio of their lengths, or the corresponding lengths, so share of matching length is 7 to 9. So we're not even told what the shapes are. It doesn't really matter. In fact, they could be circles, ovals, hexagons, it could be anything, right? So as long as they're similar shapes, so one's an enlargement of the other or a reduction of the other, just simply taking the square root of both terms of the ratio will give you the ratio of their matching lengths.